All right. Okay. Yes. A happy Monday to you. It's week 5. We're approaching, I guess, the halfway point of our spring quarter. And that means some of you are just like 5, 6 weeks away from graduation. So that is exciting. All right. Finally, we'll get into Pandas this week. So Pandas is the kind of the package, the module that will power data frames in Python, and pretty much kind of all of your data analysis will be not all of it, but a lot of it will be powered through Pandas, and you want to become comfortable and familiar with working with Pandas. There are a lot of similarities between Pandas and dplyr in R. Today's lecture will just kind of focus on the very basics of kind of creating a data frame and then subsetting a data frame, because that's quite a bit of quite a bit of it, and the notation, the syntax is a little bit different, and there are certain things that distinguish a Pandas data frame from a data frame in R. There's a lot of similarities, but there are certainly some differences as well. Okay, so Pandas is built out of NumPy arrays. Okay, so NumPy creates, the NumPy arrays, and that's set in such a way that, basically all of the values in an array have to be of the same data type. And then Pandas will create data frames. And basically every column in a Pandas data frame is going to be a NumPy array, right? Yeah, okay. And so this kind of allows us to kind of have, a traditional table form. And, each of your columns will be different data types, okay? These are going to be some important references that you should keep on hand, and this will kind of cover, these references will cover a lot of the attributes and the methods and the different things, and I'm just kind of dealing with a a small subset of these things. Okay, so you will import NumPy as NP, and you will import Pandas as PD, and so this is kind of the accepted convention that when you see PD, that's Pandas, and NP is NumPy. All right, the basic data structure in Pandas is the series, and this is basically what's going to form all of your columns in a data frame. Now, the data frame, the columns in a data frame individually will be what's known as a Pandas series, and you kind of make it just like you would make an array, except you throw it inside a pd.series function. Okay, so to kind of create it, you'll enter the data as some kind of list or something. You can also provide an index, and if you don't provide an index, Pandas will create an index for you. And basically, an index is the equivalent of a row name. So when you create your data, your data frame is going to have basically row names, and that's known as the index. So here, I'm going to create a series out of this list of floats. Okay, I got 0.25, 0.5, 0.75, 1.0. And so I create this, I can call it data. And when you print out data, you get this. This is what the series looks like. The values 0.25, 0.5, 0.75, 1.0 show up in this column, and they go along with the index. Okay, I did not provide an index, so by default, Pandas creates a zero-based integer index to go along with this. All right. You can also ask, what is the and when you print out a Pandas series, it tells you the data type that's stored in the series, that the values are float 64s. Okay. If you ask, what is this data type, it's going to come back and it's going to say it's a Pandas series, basically. Okay, you get pandas.core.series.series. Okay, but basically, when you see this, this is a Pandas series. Okay, and if you just ask for what is the data, this is basically what it looks like. It looks exactly like that. Okay. All right, so this is your basic Pandas series here. You can kind of just get the values themselves. All right, so if I take the series and I do data.values, it returns a NumPy array, okay? And you can ask, you can just kind of double check and you can say, what is this data type? And this is a NumPy array. So the values are stored in a NumPy array, but when you pair the values with an index, or a pandas will basically take those values and pair them with an index. If you ask what is the index itself, it comes back and pandas says, you know what, this index is a range index, basically starting at 0 and going through 4. Okay, so you get something called a range index. And there's different types of indices. The default is the range index. It's going to be a 0-based range index. But you can create other types of indexes as well. Okay, so once you've created a series, you can begin to subset it just like any other kind of Python iterable object. So here I can say, what's the value? This is in the index 1 position. Okay, so the index 1 position is the second value, right? And so it started off at 0.25. The second value is 0.5. And that's what we get. And then when you ask, well, what is this data type? It comes back and it says this is a floating point value, float 64, NumPy float 64. This is a floating point value. Just like a list or a NumPy array, you can slice it. Okay, so this is basically, it is a NumPy array. So if you the values at least, and so you can say, I want to slice from basically 1:3, and that's going to give you only 2 values, right? Because you're kind of slicing from the first comma to the third comma. So that's going to give you the values at index position 1 and index position 2. And this thing, because it's returning 2 values, it's going to retain the series structure, right? So if you only get back 1 value, this is not a series, it's just a floating point value. It gets simplified. Whereas if you slice the series, and it gets back more than 1 value, you're going to get back a series. Okay, so pandas will simplify, or the pandas series simplifies if it returns only 1 value, right? And you can also perform fancy indexing, right? So here I can say I want to select value 1, value 0, value 1, value 2, and it has no problem kind of repeating back the value at that position. So at position 1 or index position 1 is 0.5, and it has no issue returning it because we asked for it multiple times here. So and it will return it there as well. Okay. So by default, pandas will use a 0-based index, but you can specify the index yourself. And so here I'm creating an index. I'm creating the series, the same values as before, but this time I'm specifying the index, and the index I'm specifying will be A, B, C, D. And so now my series looks like this, okay? And the values are still a NumPy array, and the index, okay, is much like an array, okay, but except it gets labeled an index object, okay, an index. And here it says data type object. Anytime you have strings in a pandas data frame, there's no string type. You can't have a column of just strings. Everything becomes object, okay? Object is kind of a mixed data type. It allows for strings and numeric values together. So, I talked about, I said, every column is basically a NumPy array where everything's the same data type. And that's true, except when you have strings, it's going to get put into an object data type, and an object data type allows for kind of mixed values. So if you've got numeric values and Boolean values, it's going to retain that data type. You can have a column of just integers. You can have a column of floats, and if if you insert a float into an integer column, it's going to upcast the integers so that everything becomes floats and things like that. Except if you have strings, it's going to just automatically be an object, and it's going to allow for kind of mixed data types there. All right, so anyway, here I've specified the index, okay? Now, when you specify the index, you can still take the series and subset based on index position. So I can still go, what is the value in this series at index position 1? And it says, okay, the value at index position 1 is 0.5, okay? But now that we've also specified the index names, I can also subset or select values using the index name. So I can say, what is the value associated with index A? Okay, so again, here's what our series looks like. Okay, and the series is just basically one column of values, except we've got basically row names associated with it. So index position 1 is going to be 0.5, and index A is going to be 0.25, and we can select those values as such. All right, you can continue slicing with indexes. So you can say slice from the 0th comma to the 2nd comma, and you will get back rows A and B, or the first 2 rows. You can also slice using the index name itself. Okay, so here we're going to say slice from index position A to index C. Okay, when you slice using the index names rather than the numeric positions, the place that you slice to will be inclusive. Okay, so here we slice at basically comma positions, but here we're basically slicing from A to C, and C is going to be included. It's not. It doesn't just go from A to B. I hope that makes sense there. All right. So so that's how slicing with Pandas series works. Okay. You can also create a series from a dictionary. All right. And if you create a series from a dictionary, it's going to use the keys as the index values, and the value will become the value in the series. All right, so I'm creating a dictionary based on kind of the first Avengers movie here. We have a question. It says, with index slicing, we would have to make sure that A, B, C appear in that. Yeah, so it goes from basically, so it doesn't have to be, it doesn't necessarily have to be in alphabetical order here. You can slice from basically this position to this position. So, if here we put it in ABC, but basically whatever order it appears in, you can slice as such. Okay, so here I'm turning the dictionary and I'm turning it into a series. So I have a kind of sample dictionary and I put it inside Pandas series and I call this the sample series. And so this is going to be a series object. The values are in over here. And over here is the thing. Okay, so question says, you could index like R if you set up the index starting at 1. So yes, you can. It can get a little confusing because certain things will still use index-based positioning and other things will use the index that you provide. And so I'll show an example of that a little bit later. But yes, you can create the index yourself so it starts at 1 and subset accordingly. Okay, so here we can ask what's the index in this series, and we get basically the character names. So if you're not familiar with the Avengers, the Marvel Cinematic Universe, these are basically the characters' names, and then these are the actors who play them. Okay, and so this is what we have here, and then whereas the values are the actor names here. Okay, and so I've created a couple other dictionaries to store some information, and so this is these are the ages of the characters in the movies, and this was in the 2012 movie, which is almost 10 years ago now, but apparently this is a guess as to how old the characters were in-universe age of these characters. Okay, so I don't know. All right, and then over here we have their kind of superhero name. All right, and so character Steve Rogers is known as Captain America. Natasha Romanoff is known as Black Widow. Thor doesn't have a separate name. He's just Thor in the entire universe, so there's no secret identity or something like that. Okay. And so so here we have a series, and now we'll create a data frame. Before I do that, let me give you your first view quiz answer for today. Today's view quiz answer is the letter B. The letter B as in bear. The letter B is your first view quiz answer. Okay, so so I'm going to show you a bunch of ways of creating data frames. Okay, and so one is you can give it a dictionary of series. Okay, Pandas series. Each of these are Pandas series that we've created, right? So I've got sample series is this series. Okay, and then we've got ages, which is the series of ages, and hero names is a series. All of these, we took the dictionary and turned them into a series. Okay, so these are all series. So here's a dictionary of series where I have the column name, and so I got actor, hero name, and age as the column headings, and then the series themselves all appear here, and so they get put in. Okay, now by default, when you create a data frame, it's going to take the index. Okay, so here the index is listed off. You know, the dictionary gets created in this order. So in this dictionary, I'm sorry, I create this dictionary, and when I create this series, it goes in just the order that I've created, right? Tony Stark, Steve Rogers, Natasha, Bruce Banner, Thor. It just gets created in that order. But then when, and here I have, this is in a different order: Thor, Steve Rogers, Natasha, Clint, Tony, and Bruce. Okay. By default, when you create a data frame with some kind of, with a bunch of series, by default, it's going to alphabetize the index. Okay, it's going to put the index in order. So Bruce Banner shows up first, then C for Clint, N for Natasha, S Steve, TH Thor, TO for Tony. Okay, and gets put in that order, and it matches everything up. Okay, it matches everything up. So Bruce Banner's played by Mark Ruffalo, who plays, and Bruce Banner's hero name would be Hulk. And I think in that universe, he's 42 years old. Okay, and it's and it matches up the values, even though they are not in the kind of the correct order, or in that particular order as far as the series individually themselves go. Okay, and so this is different from R. In R, when you kind of take vectors, you can put vectors together, but it's just going to paste the vectors in whatever order you presented them. Here, everything kind of needs to have matching indices, and when it's going to line up the indexes accordingly, and then by default, it's going to kind of put the index in this order here. Okay, and so once we've done this Avengers thing is a data frame. Is that okay? And so, oh, I forgot to point out. That's because so Thor doesn't is basically a missing value, and so here I'm using numpy.nan to indicate a missing value. Python doesn't have a designated missing value, so you kind of just use the not a number as the missing. That's kind of the de facto way of creating missing values in Python. Okay, and so that is allowed as far as kind of you can mix the NaN type with strings everywhere else. Okay, so this is kind of one way to create a data frame. Other ways is you can create, you can take dictionaries. So here is a list of dictionaries, and we can create a data frame out of this. Okay, So I have a dictionary where A goes to 0, B goes to 0, A goes to 1, B goes to 2, another dictionary A2 and B5. So I have 3 different dictionaries, each with the same keys. And then I can say, turn this into a data frame. And it lines it up, okay? A becomes, we get 0, 0, 1, 2, 2, 5. And here I've specified the index. So rather than getting a 0 index, it's going to show up index 1, 2, and 3 here. But if you have a dictionary, a series of dictionaries, and this applies the same with the series here. If I had a series, like if I had another character in here, like Nick Fury or something like that, that would, you would create missing values. So here I have an index A, B, or sorry, not the index. I have a third column, another key, C, and so we're going to get missing values. And so here we get 0, 0, and there's no C key C here, so we get a nan, missing value, 1, 2 nan, and then 2 nan 5.0, okay? So one thing you'll notice is the column A remained integer, 0, 1, 2, and then column B, originally when I entered the data, they're integers, 0 and 2, I didn't put decimals there. But when they get put into this column, because of the nan type, the nan type is a floating point number, it upcast all of the values into floats. So now we have 0, 0.0 and 2.0, okay? And then, and with C, we have nan types, and so 5 gets upcast into a floating point value here, okay? There, in Jupyter, when you render your Jupyter's things, when you call print on the data frame, you get kind of this typewriter font, okay? And then, but if you just return the data frame directly, okay, so here, you know, because I called print, there's no out here, there's no out 28. It just prints to the screen, it gets printed in the typewriter font. If you call just the data frame and it returns the data frame itself as the output object, it gets rendered in, I guess, what we call pretty print, where it also features kind of this dynamic highlighting as you hover over it. Okay. All right, so question. In this case, the dictionary keys become the data frames column names. Yes. So in this case, I've got a list of dictionaries and the keys become the column names. Okay. Over here, I provided one dictionary, and the dictionaries, the keys become the column names, and the values are the series themselves. There are differences here, okay? And here I have a list of 3 separate dictionaries where each dictionary basically corresponds to one row, and the keys become the column names. Okay. You can also take just a dictionary and convert it to a data frame. And so here I have a dictionary, and the keys will become the column names, and associated with each key is an array or a list, okay? And here the lists need to be of the same length. So I have A goes with list 1, 2, 3, B goes with list XYZ, and this will create a data frame where A becomes the column, and I get 1, 2, 3, B becomes a column, and we get XYZ. Okay, and then because I didn't specify an index, it defaults to an zero-based index 0, 1, 2. However, here, if I try to create a dictionary or a data frame, and my dictionary of keys and values are of different length, these arrays aren't of the same length, you get an error here. Okay, so here column A has 1, 2, 3, 4, and column B only has XYZ. Okay, there's a mismatch. This one's length 4, this one's length 3. That's going to raise an exception. Okay, it's going to say the arrays are not of the same length. Okay, and then another way you can make a data frame is you can take kind of an existing 2-dimensional structure and basically give it column names and row names, or an index, and it will turn it into a data frame as well. So here I have a 5x2 NumPy array. So I've taken just these random integers and I reshaped them into a 5x2 array. All right, so this is the 5x2 array. And then I can turn this into a data frame, right? And here I called print on it, so you're going to get kind of the typewriter font here. And so when you call the data frame, you can just call data frame on the data. And then, and here I've specified column names. We got column X and column Y, and the index values are going to be A, B, C, D, E, right? And again, index is optional. And so this is going to be the result here. All right, so that's the creation of the data frame. I get probably, I spend some time creating data frames, and so these are all kind of simple examples that you can kind of create. Probably, this is probably going to be a commonly used method that for creating the data frame, this one, where you're going to create a dictionary for the column names and just list off some values, okay? But this is also fairly common where you have a dictionary. Each dictionary corresponds to a row, okay? So this is ways to create data frames. Probably the most common way of getting a data frame in Python, though, is going to be loading a CSV file. And I'll show you that at the very end, where you just kind of call pandas, read CSV, and it's going to create a data frame out of a CSV file. That's because generally you will not be typing your data in very often. You'll be reading it in somewhere, okay? But sometimes you just need to create like a quick, like a 4-row data frame or something. And it might make sense to just type it out. All right, once you have the data frame, you can subset it, okay? And so the data frame comes with kind of two attributes. You've got the dot columns and the dot index attribute, and it will give you kind of the information that you want, right? So here I can do, this is the Avengers data frame, and it looks like this. I can do Avengers.columns, and it prints out the index, and I can do Avengers.index. I'm sorry, Avengers.column will give us the column names. Okay, we got actor, hero name, and age, and then Avengers.index gives me the row names, or the index, which is basically the characters' names, the Bruce Banner, Clint Barton, et cetera, et cetera. Okay, and then once you have that, or once you know kind of the column names and stuff, is you can select columns using either dot notation or square brackets. Okay, so here I can just do Avengers.actor. Actor is one of the column names, and so actor, the column name, basically becomes an attribute, and you can just do Avengers.actor, and that's going to pull out the actor column as a series. Okay, so we get the actor names, and again, it's a series, so I'm at a lost words. The index is retained. Okay, if your column name has a space in it, you have to use the square bracket notation. Okay, now square bracket notation will work for, like, I could put quote actor in here, but here you can do square bracket notation, and this will extract out that column as well. So the hero name gets pulled out, and we get Hulk, Hawkeye, Black Widow, Captain America, etc. Okay, so these will get extracted, and these are again, once you extract the column, this is a Pandas series, right? And so all of the kind of the subsetting operations that work for series will work for these things, right? So you can do Avengers.actor position 1, okay? And so position 1 is index position 1 is the second row. That's going to be Jeremy Renner, okay? Here you can also do some kind of Boolean-based subsetting here. So you can say, give me from Avengers.actor, select where Avengers.age is equal to 42, right? So there are in the data set, there are 2 characters. So just coincidentally, I think, you got Bruce Banner, Clint Barton, and Tony Stark, and they're all like right around the same age. And so we have 2 characters that are age 42. And so you can say, give me where this column, Avengers.age, is equal to 42. All right. And similarly, you can use, you can subset using the values. So we can say from Avengers hero name, which is the column name, select the one that corresponds to that has the index Steve Rogers, right? So you can specify the index using index names. So that's going to be Captain America. And similarly, you can also slice, okay? And again, when you slice, it's going to use the order that appears in the data frame, which by default, when you turn a series into a data frame, it's going to put the index into alphabetical order, right? And so here, if we pull the hero names for characters Steve Rogers through Tony Stark, we also, Thor gets captured in that slice as well. Okay, let me give you your second view quiz answer. Second view quiz answer is D. D as in dog or data frame. D. D is your second view quiz answer. Okay, so with Pandas data frames, probably the most common, one of the most common tools that you'll be using is going to be the dot location attribute. And this is used to kind of subset your data frame using the index names. And so here you can say, basically you can ask for the row that corresponds to Thor, okay? And so when you call Avengers.location Thor here, you're going to basically get the row, and it gets returned as a series as well. This is a series, and the series will be contains the column actor is Chris Hemsworth. There's no hero name for Thor, that's just his name, and the age is something like 1500 years old or whatever in the universe. And so so this gets pulled out as some kind of series here, okay? This is, and again, if you do the ask for the data type on the dot location, it's going to say it's a series. And then as far as the values go, it seems a little bit strange, but this is a NumPy array, okay? And it feels a little bit confusing because you feel like, how can a NumPy array have different data types? We've got an integer, we've got a float, we have an actor. There's something, NumPy actually allows for what's known as a structured array. In a structured array, you can say the value in the first position is always going to be a string. The value in the second position is always going to be a float. The value in the third position is always going to be an integer. And NumPy does allow for an array that contains mixed data types as long as you structure it and say, in this position, it's always going to be this data type. In general, NumPy arrays assume that the values are all going to be of the same data type. So as soon as you put, you can have an integer array, and as soon as you replace one of them with a float, it's going to upcast the entire array into floats. But you can get around that by structuring the array and specifying that certain data types. I would say it's not something that's done very often manually, but it is something that you encounter when you're working with Pandas, because it kind of creates these structured arrays as you're just working with Pandas. Okay, so here you can also just kind of pull out a column using the Avengers.loc. Okay, and so here we're going to say select all the rows. Okay, so here using kind of the slice notation of blank colon blank. Okay, and you don't have to put the spaces here. I only put the spaces here for just visual purposes here. So, but I've got the colon, comma, so that's going to select all the rows, and we're going to select the column age. Okay, and when you do this, this is again a series, just like we've seen before. This is Avengers.loc. This is equivalent to just doing like Avengers.age. Okay, but it's the dot location attribute is very flexible as far as kind of selecting certain entries. Okay, and then again, the values themselves are stored in a NumPy array. Okay, and so once you have this, I think this is kind of familiar notation where you can kind of specify the row and the column. And so you can say, you know, what's the value at Steve Rogers and age, and it comes back as 104 or something like that. Okay. So this is the .loc, okay, which allows us to specify using the kind of the index name. And then you have .iloc, okay. .iloc will subset using the index position, and it's always going to be 0 indexed. So the .iloc is always 0 indexed, and you just use kind of the index position. So here we can say, give me an index row 3. Index row 3 is the Steve Rogers Captain America, okay? And so the name for that index row, index position 3, is Steve Rogers, and we got it's got the information there, okay? You can also kind of say index position 0, 1. So this is the 0th row, Bruce Banner. Column 1 is the hero name, and that's going to be Hulk here, right? And both of these things can be used in conjunction with assignment, okay? So here I'm just saying take Avengers.location in position Thor and age, set that equal to 1500. It used to be like 1493 or something. And then we can say in .location Thor hero name, set it equal to Thor instead of Nan, and it sets those values into the data frame. Okay, you can also set multiple values at once. So here I can say Avengers.location Thor in hero name and age, put in these values, the Nan and 1493, and it has no problem. It can assign both of those things at once. Okay, so you can use .location or .iloc in conjunction with assignment, and you can do either one or multiple values at once, and it will assign it to the data frame. Okay. So if you have a numeric index, so here I'm creating a data frame and I'm specifying the index kind of R style, where the first row is index position 1 rather than the 0 index. You can do this, but you just have to be a little bit careful because the .loc and the .iloc will have, you know, different behaviors. Okay, so if you have a numeric index that's 0 index, .loc and .iloc will have the same kind of same outputs. But here, because the index starts off at 1, when I say give me the row at position 1, we're going to get this row basically. Okay, we get 11 and 2. A is 11 and B is 2. If I use .iloc, this is 0-based index, 0-based index 1, okay, comes back and it says that's going to be value 12 and value 4. Okay, and you can kind of see it right here. It's going to say, you know, the name for this index position, at least, is the name is 2. Okay, so does that kind of make sense when you use a numeric index that's not 0-based in 0-based? Okay, and so these things will have different behaviors, and it's easy to get mixed up. So generally, if you're going to have if you want a numeric index, I generally recommend using just the 0-based index, so you don't kind of confuse yourself between loc and iloc. Loc is great if you're going to have kind of a text-based index. So if you're going to say, you know, the index is going to be, you know, people's names or whatever, that makes perfect sense, and using .loc is a great way to go. Okay, a numeric index, generally we use 0. So here, if you try to do something like iloc 3, right? So we only have 3 rows. This is numeric index location 2. There's no index location 0-based index for 3. And if you try to do something like that, you're going to get an error here. Okay, you get an index error basically, and it comes back and it says this doesn't work. All right. Here are a couple examples of using .location in conjunction with other features and things that we've learned to kind of subset. So here you can do something like, I want the rows. So we're going to do Avengers.location, and we're going to use it in conjunction. We're going to say we want ages less than 50, Avengers.age, and greater than 40. Okay. And so you can use the and to kind of for bitwise or element-wise Boolean comparison, which is how we would go about doing this. Okay. And you just, you have to put these kind of Boolean expressions in parentheses. Otherwise, Pandas or Python will complain that the logical expression or the Boolean expression is ambiguous. So if you leave off the parentheses, it's going to get confused. Okay. And here we specify which columns we want. We want the hero name and the age. And so we get the characters who are between 40 and 50 years of age. Okay. Here I've got, we can take the index, right? So this is basically the row name. Now, the row name itself is an index, but you can kind of convert it into a string so you get the string methods available. So you can do index.string str, and this will create, this will give us access to all of the string methods. And so here I can use one of the string methods, which is starts with the letter, with the character capital B, right? And so this, and then I say, give me all the columns. So this gives me Bruce Banner, and which is the Hulk, and et cetera, et cetera. Okay. Here's just kind of another example. So here we're going to take the index and we're going to do string, and I want there's no string method for contains. You can do oh, you know what? You can do in. Okay, I have an idea. Maybe that would work, but this also works. So you can do .find. .find will search within a string, and it generally gives you the index position, right? It'll say, when I searched for the character capital R, it was in index position 3, it was index position 8, or whatever. Okay, and if it doesn't find it, it's going to return a -1. So if it doesn't find the character, it returns a -1 for the find. And so here we're going to say, take the search for the capital R and give me the rows where it's not equal to -1, meaning that it did find the capital R. Okay, and so we get Natasha Romanoff, Steve Rogers, which both have a capital R in their name, and those get returned. Okay. Can you use other columns the same way? Yeah, you don't have to do the index. You can take basically any other column and do stuff like that, right? So here I did Avengers.age, but yeah, you can subset using Avengers, .actor and things like that. Okay. Other commonly used data frame attributes. So again, check the reference, but these are probably other ones that are used. You can take the data frame and do .t. Capital T will give us the transpose. So now the column names become the index, and then the index become the column names. All right, and it gets it just kind of it transposes it. You can get what are the data types? Okay, the data types will give you basically it's kind of like the structure on in R. You can ask for data frame and ask for its structure, and it tells you, oh, this column has integers and this column has type double or whatever. Data types on a data frame .d types will give you basically similar type of information. And you can also ask for the shape, which will basically give you how many rows and how many columns you have. So the .shape. And this is a lot like the NumPy results there. Okay, and so this is just very quickly, I'll show you how to read in data with from some kind of CSV file. There's other methods. Read CSV is probably the most frequently used, but you've got like read txt. I don't know them, all of them off the top of my head, but basically we'll do pandas read data. Let's see, read and write. Okay, so you got read CSV. Okay, you've got read pickle, read table, read fixed width file, read clipboard, read Excel, read JSON. You got all of these read type of things. Okay. There's you can also put in read SQL query, and you can specify a SQL query to kind of get all of these things. So there's lots of flexible ways to get data into it. Read CSV is probably the most commonly used thing. Maybe I should link the input output thing. But well, anyway, all of these are in here. Okay. So there is just a CSV file. You can give it a URL and it will find it, or you can give it the name of some kind of path that exists on your computer, right? So if you have the CSV file in your working directory, you can just put the name of the CSV file. But if this data set is available, just at some, URL here, whoops. Okay, so here's just the data set located at the URL. You can just read that in directly, which is a nice feature of Python. You can just give it a web address, read it in. Okay. And then so here, if you say, well, what does this data set look like? By default, it's going to print out the first 5 rows and the last 5 rows and give you a ... for everything else. Okay. Okay, and so this and tells you 891 rows, 11 columns. Okay, and you can see, so by default it creates a zero-based index, and there's also a one of the columns is an index already. Passenger ID starts off at 1 and ends at 891. And we can fix that a little bit later. Again, just the same attributes that we looked at before: .shape, .columns, .index. And so the default index again starts off at 0 and ends at 890. Okay. You can ask for Titanic.info, which is similar to Titanic.dtypes or the dataframe.dtypes, which I showed you on an earlier slide. .info gives you a little bit more information. It tells you how many values are non-null. So some of the things are missing values, okay? And so they're going to appear as NaN types. Let me see. Maybe not age, but under cabin, we have some NaNs, okay? So this is kind of like what their room number was. And so we have some NaN values. We also have, NaN values in age, okay? And so, so all of those NaNs show up as, however many you have. So you have 891 non-null, but then, some of them some age values are missing, some cabin values, or a lot of cabin values are missing, okay? And, some of these are integer types, and then, basically string values are going to be object, which also allow for missing, right? So kind of the NaN values show up here. Okay, and then there's one method that's pretty useful, and this you can do .describe. .describe will take basically give you a summary statistics for the numeric columns. Okay, so these ones that are object will not get .describes. Okay, but basically everything that's numeric, so fare, age, passenger ID, survived, P class, and things like that, you'll get numeric values, right? So survived is just a 0 or 1. And so you can see the mean survival, which will be kind of the proportion who survived, is going to be 0.38. All right. As far as the age goes, as far as the ones that were available, the mean age was around 30, whereas we had people anywhere between 20 and, or I guess newborns and 80 years old and stuff like that on the Titanic there. Okay, so on Wednesday we'll go into more on Pandas stuff, working with it, but this is just some very basic things, at least for how to subset your data in Pandas. And then there's a lot of things that you can do similar to dplyr as far as kind of pivoting and creating summary values there. So we'll take a look at that on Wednesday. Let me go ahead and give you your last view quiz answer for today. Last view quiz answer is A as in apple. A as in apple is your last view quiz answer for today. Okay, we'll end here, and we'll see you guys on Wednesday. And I will post up homework 3. I know somebody asked on Campus Wire about homework 3. You can expect homework 3 to get posted up probably late tonight or early tomorrow. Okay, so that'll get posted up, and I'll give you that appropriate amount of time to work on that one. All right, we'll see you guys on Wednesday.